Hi guys, today we are going to take a look how to create this kind of effect inside Houdini. So let's jump into it. So now what we can do is we will first take a sphere. As you can see, if we bias it this out, you will see like this. After that what we can do is we will transform this sphere a little up like this in the space. We take another sphere, as you can see here, and now what we can do is we will transform this to a space as well. Now if we look these two spheres, it will look like something this. Now, my main motive is to collide this source of water with this source of water. So we have to move this sphere in this direction and this sphere in this direction. So what will I do is I'll create a velocity. This sphere velocity will point towards this sphere and this sphere velocity will point towards this sphere. So for that what I will do is I'll take attribute triangle node, as you can see. I put the sphere first sphere input in first input and second sphere in second input. Now what I'll do is if I little zoom it out like this, I take the first second sphere position and store it in pose variable like this. I take the first second sphere position and store it in pose variable, and then I'll subtract that position with the current position of the sphere, this one exactly. Now this will give a normal that is pointed towards that sphere. So if I visualize the normal, you can see it points towards that sphere. So if I just visualize this and this, you can see our sphere is here. Now this sphere direction is towards that sphere with this. Now similarly we want this sphere direction towards this sphere. So what we can do is we will put this sphere input as into first input and this is our second input. And similarly if we see this, similarly we take the position of this sphere and store it in position variable, and what we can do is we subtract that position from its current position of this sphere. So now this will give like this. If we merge this together, you can see they are both pointing towards each other like this. Now the main point is it's truly procedural. So if we move this sphere, you can see, wait, if we move this sphere in other direction, and you will see that automatically it will point towards this sphere only. If we move this sphere to this direction, it will point automatically to this sphere only. This is the magic of Vex. So I set this out. Now after doing this, I set up the velocities in this direction. Now what I'll do is I'll take the attribute triangle and put the velocities is equals to normals. Now these are the normals, so I put this velocities equals to normals into some kind of speed that I want to give, like velocity speed. So I'll put here 2. Now what we can do is I'll just switch off this normal kind of thing. You can see now there is a sphere, but we want particles for fluid simulation. So what we will do, we will create a point from volume node and fill this sphere with the particles, as you can see. Now there is a particle separation over here. You can decrease the particle separation for more resolution. This is as simple. Now what we can do is, if we can see in the information tab, there is only position attribute we don't got the velocity attribute, which is there, it's there, you can see, and normal is also there, but in this we lost all that attributes. So for that what we can do is we will take attribute transfer node and transfer the velocity from this node to this node, and you can see now velocities are there. After that, if we visualize the velocities vector, it will move like this, you can see. You can decrease the scale of the velocity by going here and just reduce this like this. Now after setting this up, what we can do is we will set the density attribute onto this sphere, like how dense this sphere is. So what I put the density attribute and put 1000 density, like how heavy the fluid is. Now after that, what we can do is I'll assign some color to it like this, you can see, and this is our source one. Same setup we used here also in the source 2. Similarly, we take the velocity and convert this into normal. Normals convert the normals into velocity and multiply it with some value so that it will depend upon the speed, how the fast the speed is. So now again we take point from volume node. If we visualize this will convert into volume, and then again transfer this out attributes, and the velocity, if you see, it will look like, wait, there is some mistake here, this as well you can see, and there is attribute triangle node. We put density to around 10,000 as you can see, and there is a color, uh, as you can see we will put white color. Now we give color here because when these two objects collide, we want to mix the colors of these two spheres. So we give initial colors like blue and like white only, and this is our source to output. Now let's move to our DOP network. So if we go inside the DOP network, let me reset this. There are two spheres like this. Now what we can do is, first we take a flip solver node that will solve the flip simulation. This is the flip object node that we connect into first input, and these are our two source node basically. So this is our volume source and this is our volume source another. So what we will do is we will select the source one from here, just copy this thing and just paste it right over here, control V, like this. Similarly, go back, copy this source 2 and paste it right over here like this. Now as these are particles, so what we can do is go to the particle tab and turn, there is a, by default this is look like this something particles. You just disable this. We don't want this particle group because it's not there. If we visualize this now, you can see there is no particle group, so that thing we don't need, so just disable this. If you take volume source like this, it automatically comes like this. You have to go to particles tab, source particles, you enable that, turn off this and put the source right over here like this. Now after that, this is our source 1. Similarly, I put source 2 as well like this. You can see same settings. And now what we can do is we'll simulate this. After simulation, this will collide with either, but now first do some settings. So what we can do is in the flip solver tab, first you have to keep in mind things. Receive particles is turned on, you should keep in mind. There is the option called surface tension. You can also enable this surface tension so that you can get the nice tendrils around the sphere. And density field, yes, we give density outside now, so you have to enable this density field as well. And final but not the least, inside the solver you should turn on use OpenCL for best solving, fast solving. And there is a flip splash you have to select, and nothing else you must do, and then simulate. Your result will be there. But now I want this particles color to be transferred to this particles as well. They mix the color will be mixed. So for that, what I can do is I'll take a soap solver. Inside the soap solver, if we visualize, there is a transfer attribute transfer node. In this attribute transfer node, we will transfer the CD attribute, and we will hug both this input in the DOP import node. Now, after the simulation, it will look like something this. We visualize this. After simulation, it will look like this. You can see something like this. Nice tendrils effect, splash tendrils effect, and you can see the colors are transferring as well. Now what we can do is we will take a retime node and retime this out. Like first it will be very fast and then slow it down. So if we play that now, you can see it will be automatically slowed down. Now in the retime node, what you have to do is you have to animate the speed only. Lower the value, slower it is, higher the value, faster it is. Now after doing all this, we have to convert this into a mesh. You can use also a particle fluid surface node, but there are some flickers sometimes, so we will create our own meshing system. So in this, what we can do is we will take a VDV from particles node. This will look like this previously, and you in this what you have to do is you have to decrease the radius scale. Previously it was like this only, so you have to decrease the radius scale like this. There is a voxel size, you can decrease this for high resolution, and there is a radius scale of these particles. After that what we can do is we will take a VDB reshape node, yeah, and choose the operation close. Now there is every particle, they are close to each other, like they are closed by each other, so this is important. After that what we can do is we will take another reshape node and little dilate this out, as you can see, and we take another smooth node to smooth this out, as you can see. Now we will take a final convert VDB node to convert this into polygons like this, polygons like this. And now we want to transfer the colors. Don't forget we give the colors as well. So for that what we can do is we will transfer the color from here and put it right over here. So if we visualize this, now you can see we get our colors back. And finally we assign material to it so that we can render it in which software you want. I recommend Redshift. So thanks for watching this video. I hope you like this video. Kindly subscribe my channel. So thanks for watching. Stay tuned for next video.